like to introduce Garrett Wagler, Lucas Hobson, and Josh Wright for their senior project.
Thank you, Professor Eller. Thank you all for coming to our senior presentation of our target training system. My name is Lucas Hobson.
I'm Josh Wright.
And I'm Garrett Wagler. So the objective of our project was to develop a system that would be used for training, reaction, and entertainment purposes at Uncle Rudy's Indoor Firing Range, which is located here in Evansville. The scope of our project was that the system would be self-contained so that no wires or anything else could be severed or be shot or anything like that to compromise the system. The targets would swing into view after being sequenced, and we would have a system to control the targets after they're being sequenced. Some terms to clear up before we actually get started. Frangible ammunition. It's different than normal ammunition, whereas what we are using is compressed copper powder instead of lead core with jacketed hollow points over it. The three calibers that we chose to use are 9mm, 40 S&W, which stands for Smith & Wesson, and 45 ACP, which stands for Automatic Colt Pistol. It's a little bit off on the slide over there, but this is what we call a lollipop target. Kind of looks like a lollipop sucker. A little bit about Uncle Rudy's Indoor Firing Range. I don't think John is here today, I didn't see him, but he is the owner of the firing range with his wife Melissa. The clients that they have daily range from beginner shooters to anyone in military or experienced shooters. They offer training classes just daily or weekly, and you can get one-on-one training with their instructors there. They have 10 lanes that are available to shoot. The maximum distance is 25 yards. You can go up to, well, it's up to 25 yards. You can go as short as 3 yards. We're actually placing ours at 25 yards. Their current setup, they have suspended steel cables that are above you that actually carry the target out mechanically. And that has a 70-inch max, which is one of our constraints.
For our initial designs, we broke it up into 4 separate assemblies. We have our target assembly, rotating assembly, center stack, and the housing. The front center stack is angled to deflect the ammunition, so there's no possible ricochet back towards the shooters. Here you can see exploded view of our initial rotating and target assembly. It utilizes a clamping fixture that rotates around the solid shaft. The clamping fixture has pins cut out so that it can securely hold the target and allows for quick disassembly in the event that a target is damaged and has to be removed. This was later revised for a more simple approach with just a hinge, and we reduced the size of the target diameter and the arm to reduce weight. And we'll talk a little bit how the target works. This is what we refer to as the home position. As you can see, the target is folded back and the car door latch has the striker bar secured in it. In this position, there's constant tension from the spring trying to pull it outward. In the release position, you can see that the solenoid pulled the lever arm down, which allowed the target to swing out due to spring tension, and this will swing the target out perpendicular to the shooter. This here is the live position. The target is displayed in front of the shooter so that they can attempt to shoot it and use that energy to swing the target back to the home position and the door latch to secure it. We designed a lever arm to increase the amount of force that the solenoids are able to pull. Due to our self-contained objective, we had to design this around a 12-volt solenoid so that we can power this with an onboard power supply. This lever arm increases the pulling force from 4.9 pounds up to 17.3 pounds. And after reviewing it, it may be practical to look further into linear actuators to achieve our force that we need to actually pull the latches to release them.
So as stated earlier by Lucas, the front is kind of like a wedge so that there's no chance of ricochet, which is right here. So this is actually what is being displayed at the shooter. This is the worst case for impact, which actually changed our moment arm to being very short, so it required quite a bit of torque to move back the target. This is a better impact point, and this would be ultimately the best one. Back here is our hinge, and this is our spring. So running the calculations, the 9mm round is actually our constraint for this because it is the smallest, but it's still flying at the fastest velocity. So we measured from back at this point here, every ½ inch for this graph. The blue line here is the 9mm, the 40 is the red, and the 45 is the green. And as you can see, the 45 is giving off quite a bit more torque at about 1,200 Newton meters.
So the controls on our system, you can see in the top left picture, we chose an Arduino Uno R3 for our controller. This was based off of cost and tutorials online and help available to either of us. We weighed the pros and cons of using a microcontroller versus PLC, but again, the power constraint came into play, and we determined this to be our best choice. Just to the right of that is our 12-volt DC lithium ion battery. This supplies power to both the solenoids and the Arduino itself. Below the Arduino is our limit switches that we use to determine when the target has been returned back to the home position and is latched to sequence the next target. Next to that is the car door latches that we use. They're heavy duty, very robust, and they'll be able to handle the forces that are going to be applied to it. Underneath that is our 8-channel SaneSmart relay board that we are using to control our solenoids. Here's a picture of our Arduino schematics. No member on our team has had much of any programming experience, so we bought a starter kit and started testing out with the different basic button programs and input programs. We're able to successfully implement those, and we are working on to completely merge it all together so it all communicates.
Getting into the fabrication of our base and the tree of our target, the first step we did was a material takeoff. What a material takeoff is, we took the design of our drawings and we pulled it all together to give us the materials. We then nested it all into different lengths, because when you buy materials from different vendors, they come in like 20-foot lengths or 12-foot lengths. So we had to get those adjusted perfectly for that. From then we come up with a cut list for us to send to the burn table and to cut out our pieces so we could later fabricate them all together. We sent out quotes to different vendors, and when they sent us back the quotes, we picked one that was most cost effective. For the fabrication, the first step of the process was to burn the pieces out using our burn table. This cycle time took an hour and a half to get from our shipping department to our burn table and for them to run the burn table, as well as programming it. Next step was to grind each of the pieces, because when you use the burn table, it leaves some burrs that make it difficult to weld. It won't hold it good well. And that cycle time was approximately 3 minutes apart, with 16 parts. Right here is a picture of the base of our system. Looking into it, the front corner was what is going to be looking at the shooter, so that the shots would deflect off rather than being reflected back. We had angles and then another piece of plate behind the angles mounted on to protect any shots that could possibly go through from hitting our control system. The next step in this process was to bend 24 by 45 inch plates at a 52-degree angle using our press brake. And this cycle time took about an hour. And our last step was to weld all of our bases together, which was the most time-consuming part of fabrication, which was 8 hours. As listed is our bill of materials. This is our metal supplies, our control components, as well as any casters and additional accessories. That came to a subtotal of $1,287. The student and fabrication cost for this project, the student hours for design and build was 55.5 hours. At a student hourly rate of $15 an hour, we came up with a subtotal of $832.50. To have it fabricated with our second process, we used one worker at $22 an hour for an hour and a half to nest all of our material together. And then another two workers at a rate of $18 an hour would be sent to fabricate the parts. That come to a subtotal of $393. The total cost and payback period. The total cost for the project was $2,512.38 for time and material, and we forecasted this to be rented out at Uncle Rudy's twice a week at a rate of $10 a session, which come up with our payback period to be approximately 26 weeks.
So a system that is currently on the market now is called Fulcrum Target Systems. They have pop-up, turn, and side swing targets. Our design only has side swings. Theirs are ran off of motion control and an actual controller. The difference between their targets and ours, theirs are paper, so they can actually shoot regular rounds through them. The risk with that is you have to have a backstop. With ours, you don't have to have a backstop. If you hit it, it just dissipates. Another thing that they have going on for them, their base right here is made up of a waterproof case. So it's very modular, it's very, it can be small, it's transferable. And its market price is $4,200.
Some major learning experiences we had throughout this project. Communication proved to be a major obstacle for us. From getting our ideas relayed to the customer, as well as getting his ideas back to us on what he really wanted. From there, we went to taking our design ideas and relaying it to the shop. When we were designing, a lot of things with us not being professionals were not completely defined, so we had to make adjustments while we were fabricating this product. Some additional experiences we had was a lot of hands-on experience as far as grinding and welding and getting to use the tools inside the shop, as well as using critical thinking. We came across obstacles that we couldn't just shy away from and run away from. We had to overcome them and find a way through.
A few of the steps moving forward. First one would be to consider utilizing linear actuators in place of the solenoids to achieve our force that we need to open the latches. With that would be determining the proper spring size and spring rate that we need to swing our target out perpendicular to the shooter. Another option would be to modify the center stack to reduce weight, reduce material costs, and The next two things are with programming, need to debug and finish our sequencing programming and be able to add our wireless connectivity to use at their range with their wireless network.
We would like to thank our advisor, Mr. Eller, the owners of Uncle Rudy's, John and Melissa Rudolph, the staff there as well, Dr. Mitchell for all his help, Ms. Moore, Dr. Cuban, Mr. Singleton, and Mr. Brown, which helped with the fabrication, Mr. Nelson, Mr. Kicklighter, and Mr. Amos for all of their input and support through this project. And we'd like to open it up for any questions.
All right, questions?
Good job. With regard to your nesting, is that something that you did by hand, or did you use some type of computer program to organize your cuts into an optimal layout?
We had a computer program at work that I used.
Do you know what it was called?
I don't.
Other questions? Let's see, on your competitor's product, could you bring that one back up? Is that base made out of plastic?
It is.
Yeah, so it's waterproof, but
It is not bulletproof.
I'm thinking yours might last a little longer. Just a thought there.
Quarter-inch steel will last a lot more than plastic.
All right. Any other questions?
Hi, guys. The idea of using the door latch, is that something standard that you see in other target practice devices, or is that something that you guys came up with?
Actually, we didn't initially design for that. We were going to use a pipe that would swing around, but in the middle of fabrication, we actually had some hinges laying around at the shop, and we kind of started looking at that and went from there using that idea.
Well, that's a neat idea.
Thank you.
All right. Any other questions? If not, let's give them a hand.